Hello students, welcome back to another screencast. This one is about indirect measurement, something we practiced in class this week. Let's see it in action again in a real-world situation. Then I will present to you your own real-world situation and you will solve it using very similar techniques. Here we go. This one is about a place in Utah called Bryce Canyon National Park. It's known for its unusual rock formations, and here's a picture right here of its very unique and unusual rock formations. As you can see, unusual is definitely the adjective that would describe it. One particular rock casts a shadow 21 feet long, and a girl standing near this rock is 5 feet 3 inches tall and casts a shadow 7 feet long. I know it doesn't say it, however the question is, of course, how tall is the rock? Now, as you have seen here, I have sort of tried to replicate in drawing form one of these rock formations that we need to solve for. Now, of course, like we said in class, you don't have to be Picasso or a Rembrandt in order to draw your pictures. Okay, just a nice little doodle is enough. So here's our rock, and here's the picture of the girl. And as you can see, here she is, moving around. Oh, look at that, I'm in Bryce Canyon. Look how lovely all those rocks are. Yes, of course. And then here, right here, is the rock that we need to do and work with. So it says the rock casts a shadow 21 feet long. All right, so again, it doesn't have to be anything phenomenal. Here's the shadow of the rock. Very good. And we know it is 21 feet long, so I'm going to represent that as 21 feet. And then it says, a girl standing near this rock is 5 feet 3 inches tall. We're going to come revisit that in just a moment. So let's label right next to her, she is 5 feet 3 inches tall. And she casts a shadow that is 7 feet long. So again, here's her shadow, and we will label that as 7 feet. All right, now what we want to do is, we need to create a proportion. But before we do that, in fact, one thing you have to understand whenever you're using this indirect measurement is that all of your units need to be in the same unit. Yes, we are all talking about distances, lengths in feet and inches. However, 21 feet is only in feet. 7 feet is only in feet. 5 feet 3 inches, what we want to do is we want to convert 5 feet 3 inches into only feet. In other words, we need to represent 5 feet 3 inches as a decimal. In order to do that, however, we have to actually consider what 5 feet 3 inches is telling us. Now we know 5 feet 3 inches, of course, is going to be 5 point something because the whole number 5 represents how many feet we're talking about here. So let's write this out. We know this is 5 feet 3 inches. Now the 5 here, as we have just said, that's going to represent the whole number. The 3 inches, that's going to represent the decimal. So what we have to do is we have to consider what 3 inches is. Well, what we know is that a foot has, of course, 12 inches. So this 3 inch is representing 3 inches out of 12 inches, of course. But we know 3 out of 12 is more accurately put as 1/4. Now, through long division, or just because 1/4 is such a common fraction, we know 1/4 is, of course, 0.25. So the 3 inches is representative of 0.25. In other words, 1/4, 1/4 of an entire foot, which makes sense because there are 4 3-inch groupings within 1 foot. 3 inches, another 3 inches, another 3 inches, and then a fourth 3 inches make 12 inches, aka 1 foot. Thus we know that only 3 of those inches is 1 out of 4, 1/4, in other words 0.25. So therefore, what we know is that this 0.25 is going to come down, and it's going to be our decimal, and the 5, of course, is just going to remain as 5. So 5.25 is the exact same thing as 5 feet 3 inches, and that, ladies and gentlemen, is going to be the number that we use in our proportion. 5.25 feet, same thing as 5 feet 3 inches. All right, so now that we got that out of the way, we know that 5.25 feet is the number we're going to use to represent the female's height. We can now finally start setting up our proportion. And we have to match up corresponding sides. But again, since we're not dealing with, rectangles, triangles, quadrilaterals, things like that, matching up the quote-unquote sides is a little bit of a misnomer, slightly misleading. However, the concept remains the same. If I were to ask you what's the corresponding quote-unquote side to perhaps the shadow of the rock, which is 21 feet, it would also be the shadow of the female, which is 7 feet. So one way we can set this up is we can say 21 feet over 7 feet because the 21 and the 7 are corresponding sides. Now, what is that we're trying to find? We are trying to find the height of the rock, which we don't know. So let's call that, let's call that R, just to shake things up. I know we normally use X, but let's get a little crazy here. Let's use R as our variable. Why? Because we're rebels. That's right. Oh, R stands for rebel too. Now, okay, moving on. We also know that R, our rock, and the height of the female, 5.25 feet, are also corresponding sides. So let's set them up that way. Now, one thing we know is that 21 is in the numerator, so therefore any other number or variable from the part that has the 21 feet must also be in the numerator, in that case, R. And as we just said, R corresponds with the height of the female, which is 5.25 feet, which is what we're going to use right now, 5.25. So here we have our wonderful ratio all nice and set up, our proportion, our two ratios in proportion. So what we need to do is solve for R. And we can do that multiple ways, of course. One way that we have been learning in class is, well, see if you can reduce one of your fractions. Let's look at this one. 21 over 7. Does it have a common factor between 21 and 7? I believe it does. That would be 7 itself. That's right. So let's think about this. If I have 21 and I divide it by 7, what do I get? Well, of course, that would be 3. And if I have 7 and I divide that by 7, what would I get there? Well, that would be 1. So 3 over 1 is this exact same thing as 21 over 7. So this is still equal to R over 5.25. And we continue from there. See, by reducing it, we've kind of made these numbers a little bit easier for us to work with because we know that the means extremes property tells us to do 1 times R, which we know is 1R, or just simply stated as, of course, R. So we don't really need that 1, but if you'd like to leave it there, you can. And we also know that 3 times 5.25, we can do that pretty accurately using our brains because they're so strong. Let's see, if I want to do 3 times 5, I know that's 15. And if I want to do 3 times 0.25, in other words, 25 cents we can think of it as, well, 3 quarters, 3 25-cent pieces, would give us 75 cents. You see, the way I did that was, instead of thinking of it as 5.25, I thought of it as 5, and separately from that a 0.25, and multiplied each of those pieces separately. 3 times 5, I know, is 15. 3 times 0.25, I know, is 0.75. So therefore, 3 times 5.25 is 15.75. So I know that this is 15.75 feet. That's how tall the rock is. That's pretty tall. But one thing we want to do is we probably want to put this back into feet and inches as opposed to just feet. In other words, we need to figure out what 0.75 feet represent. Well, we can think of that a few different ways, in fact. In other words, our final answer is going to be 15 feet and some amount of inches. All right, let's explore how we can figure that out. Great way is to consider kind of off to the side here what 0.75 really is. Well, we know that 0.75 is in reality 75 hundredths because 7's in the tenths, 5 is in the hundredths, and because 5 is the final digit in the decimal, we ask ourselves, hundredth. When we hear that number, what do we think of? Of course, it's 100, and that's the number that goes in the denominator. But 75 100ths, we know that reduces to 3/4 by using a factor, of course, 25. Now, I'm sure 0.75 you already knew was 3/4, but here we have a proof of that. So we know that 3/4 of a foot is in fact 0.75. All right, so how many inches is that really? Well, guess what? We can still use our proportions to solve for it. 3/4 is going to be equal to some inch x out of a total of 12 inches. Fine way of doing it. And we can use the means extremes property, or we could ask ourselves 4 times what gives me 12? Of course, that is 3. So therefore 3 times 3, because if we multiply the denominator by 3, we must multiply the numerator by 3. We know we're going to get 3 times 3, which is, of course, 9. So 9 is equal to x. And in the context of this problem, we're talking about 9 inches, which is 3/4 of a foot. In other words, 0.75 inches is 9 inches. Excuse me, 0.75 feet is 9 inches. And so thus we can finalize our answer in not just feet, but feet and inches. So let's go back to our original work right here. And instead of 15 feet question mark inch, that's right, we now know that it's 9 inches. So our final answer, once and for all, the rock is 15 feet 9 inches tall. You know what? There's another way we could have found 9 inches using mathematics. We know that there's 12 inches in a foot, and we know we're dealing with the decimal 0.75. Another way we could have done it is simply take 0.75 and multiply it by the number 12. 0.75 times 12 is, of course, 9, and we still get 9 inches that way. So, however you get it, by using proportions, multiplying by the decimal, and 12, you're going to get 9 inches. So our final answer is 15 feet 9 inches. Very, very good. And that's the height of this rock. So congratulations, we finished the problem. Let's put it back into our drawing right here. All right, so we know the rock had cast a 21... Whoa, what happened to her legs? Poor girl. Anyways, we know the rock is 21 feet. The shadow of the rock is 21 feet, and now we know that the rock itself is 15 feet 9 inches tall. And we're able to get that based on all of our wonderful calculations. All right, nice job, everyone. Here is your problem to solve. This one has to do with not rock formations, but a farmer and his or her silo. Now, for those that don't know what a silo is, it's these large structures you see on farms that are used to house grain and other various things that can be found on a farm. Just know this, they are very, very tall. And that is where our problem begins. A farmer who is 72 inches tall is standing beside a silo, and that's a silo right here, that has a height of 140 feet. You know that's tall. The length of the silo's shadow is 31.5 feet. What is the length of the farmer's shadow? So now, for the first time, you're measuring the length of the farmer's shadow, knowing that the farmer is 72 inches tall, knowing that the silo is 140 feet, and knowing that the shadow of the silo is 31.5 feet. Now, I do expect some pretty good pictures here. I look forward to seeing your lovely artwork and, of course, your lovely mathematics. Remember, however, one thing I did say, all of your units must be in the same unit. Here we have inches, feet, and another feet. So ask yourself, will I change everything to inches, or will I change everything to feet? It's all up to you, no matter how you do it. As long as you do your math and your numbers correctly, everyone will get the same answer. However, I am asking everyone to leave their answer in both feet and inches. So if you get a decimal in feet, please change that and figure out how many inches represents that particular decimal by using any of the techniques that you just saw. All right, feel free to email me if you have any questions, and I look forward to seeing you later.